Welcome to another tutorial in my Forza Horizon 4 tuning series. If this is your first time on the channel, my name is Anthony and I'm a fellow car enthusiast and engineer. After watching this video, you'll be able to tune gears to match a car's power band and get maximum speed. I went ahead and saved our A800 tune from the previous video and then did a bunch of upgrades to our Supra. Now it is in S1 class with a performance index of 900. As you can see, this Supra has some serious power now. I've also reset the tuning to its default settings, and let's see how this does with the values that Forza gives you right out of the box. It's pretty clear we have the same issues from when we did the A800 build. The default tuning wants to spin out during weight transitions, and with over 1100 horsepower, it's now even more unforgiving. We also see here that the top speed test has us maxing out well before Supra runs out of steam. To do gear tuning, we will need a few details about the car that you can't get while driving around. So let's head back to our house. Pull up the Forza Tune app. Here we have the Pro version, which gives us a quick way to do gear tuning. We'll create a new tune for the 98 Supra. Then we will go into the upgrade screen and pick any of the power upgrades so we can see our stats along with a power and torque curve. We press up on the directional pad to toggle the display and grab the weight, along with the weight distribution of 52%. And this Supra is right at 900. And as crazy as it is, we only have a rear-wheel drive. We select a street tune of the standard variety, and for the cases like this where upgrades change the shape or length of the torque curve, we want to include gearing in our tune. So slide that switch and hit next. Here we have a few more items to fill out, and you'll see here it's pretty fast once you know how to do it. First, we copy over the max torque value, which is an eye-watering 924 foot-pounds. Then we come to the most commonly asked question for gearing, how to find max torque RPM. We do this via the graph. I like to imagine a line moving down, and the first point it hits on the torque curve is where the peak of the torque happens, which would be right around here, just below 5,000 RPM. With Redline, we also want to estimate quickly via the graph. The line ends past the 9,000 mark, but not quite halfway. Let's estimate around 9,300. This car has a turbo, so we will select forced induction. And we have 6 gears, which, if you are ever unsure, you can check those in the tuning menu, which we'll see in just a moment. For tire size, we jump over to the tire size upgrade option and copy the value for the rear tires. In this case, they are 345, 25, 18. Then our last step is to use the game's simulation values to help us understand how fast the car is. Press up on the D-pad again to toggle over to this view. We could use this data as shown, but it's not 100% correct when you are tuning for max speed. Let's instead jump over to the tuning menu and pull that final drive slider down inside the gearing section. We want to move it around a bit to see the lowest 0 to 100 mile per hour or 0 to 161 kilometers per hour possible for the car. In this case, 6.4 seconds looks pretty fair. And moving the final drive around also helps us determine that our theoretical top speed is much higher at nearly 268 miles per hour. We hit next again, and now we can copy our results over. We set our tire pressures, then we copy in our new final drive and gearing values, and the app tries to find a balance between top speed and acceleration. So when tuning for max speed, you'll want to move that final drive slider around until top speed is maxed out again, and the 0 to 100 mile per hour acceleration time is also faster. Now our gears are properly spaced for the car's wider power band. You will see an even bigger difference in feel and acceleration when retuning gears on less powerful cars. Okay, let's copy over our alignment values, followed by our anti-roll bar values, which are now matched for the weight distribution and weight reduction. Next, we rebalance and set our spring values and ride height, which is about 40% of the available range. Dampers are also now matched to the car, whereas the default setup we had just a second ago still had the car set up for a heavier and more front biased setup. Now braking will be 47% with whichever brake force you prefer. And as usual, for our initial build, we will do a 60-30 split on the differential. Now it's time to free this monster again and see if we tamed it a bit. The car is still a handful, like any rear-wheel drive car with 1100 horsepower. Not to mention I have traction control and stability management turned off. The Supra is definitely able to react and maneuver much better without spinning. And I'm happy with how the tune is putting the power down, considering we aren't running aero either. And now, let's see how fast we can go.
3, 2, 1.
Boom! 255, 258, 262, 262 miles per hour for that split second. It's a little bit ridiculous, but a lot of fun. And for extra credit, I'd highly encourage you to take what you've learned here and build an all-wheel drive version, an S1 version of the Supra. Now we have one more thing to do with this car and all that power. Tune in to the next Forza Horizon tuning video where I show you how to quickly convert this into a drift build.